Calculate the value of the standard cell potential, E standard. E standard equals 1.50 V, 0.16 V equals 1.34 V. 1 point is earned for the correct answer. Does the mass of the point electrode increase, decrease, or remain the same as the cell operates? Justify your answer. The mass of the point electrode remains the same because the point does not react and no Cu atoms will be deposited on the point electrode. 1 point is earned for the correct answer and a valid justification. An expanded view of the O half cell before the reaction occurs is shown in box A below. An expanded view of the O electrode after the cell operates for a period of time is shown in box B below. Visual. Assuming that the representation in box A is accurate, explain what is wrong with the stoichiometry represented in box B. In a redox reaction, the number of electrons lost must equal the number gained, so the net charge must be 0. The total charge of the cations is less than the total charge of the anions. 1 point is earned for a valid explanation. After the cell has operated for 30.0 minutes, 0.185 grams of O is deposited on the O electrode. Calculate the number of moles of O deposited. Calculate the average current that passed through the cell during the deposition of O. 0.185 grams O times 1 moles O slash 196.97 grams O is equal to 9.39 times 10 to the power minus 4 moles O. 1 point is earned for the correct calculation of the number of moles. I equals Q slash T. Q is equal to 9.39 times 10 to the power minus 4 moles O times 3 moles E minus slash 1 moles O times 96,485 C slash moles E minus. T equals 30.0 minutes times 60 seconds slash 1 minutes. I equals 9.39 by 10 to the power minus 4 moles O times 3 times 96,485 C slash moles E minus forward slash 30.0 by 60 S equals 0.151 C slash S equals 0.151 A. 1 point is earned for the correct number of electrons transferred, may be implicit. 1 point is earned for the correct calculation of the current. The student adds some NaCl to the half cell that contains Cu plus and Cu2 plus, and a precipitate forms. Based on the information in the following table, determine the identity of the precipitate. Justify your answer with a calculation. Visual. For CuCl, CuCl is in equilibrium with Cu++ Cl-. KSP equals Cu plus Cl minus. 1.7 by 10 to the power minus 7 equals x to the power 2. X is equal to 4.1 times 10 to the power minus 4 molar equals solubility of CuCl. CuCl has a lower solubility compared to CuCl2 and will precipitate first. 1 point is earned for a correct calculation of the solubility of CuCl. 1 point is earned for identifying the precipitate with the lower solubility. Write the net ionic equation for the formation of the precipitate. Cu++ Cl- gives CuCl. 1 point is earned for the equation consistent with the answer to part E. The student predicts that the cell voltage will increase after the precipitate forms. Do you agree with the student's prediction? Justify your answer. Disagree. The precipitate will decrease Cu+, which will cause Q to increase and become closer to the value of K. Therefore, the voltage of the cell will decrease. 1 point is earned for a correct choice and a valid justification.